Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, hello. In this question, we're told we have a ball that is thrown straight up and it rises to a maximum height of 16 meters above its launch point. We're asked at what height above its launch point has the speed of the ball decreased to one half of its initial value? So, where is v final equal to one half of whatever its initial speed was? Well, if we're throwing this ball up, we know that we're going to have conservation of energy. At the start, it's going to have its initial speed, so it's just going to have some kinetic energy at the start. And then at the end, we know it's going to have some speed, so it'll have some final kinetic energy, but it also has some gravitational potential energy. And we know that because it has gone up some height. So we have 1 half m v naught squared equals 1 half m v final squared plus mgh. This is going to be h final, not our maximum height here. Well, we know that our final speed is equal to half of our initial speed. So I'm going to cancel out the masses here because they conveniently go away. So we're going to have 1 half v naught squared equals 1 half v final squared, which is going to be 1/4 v naught squared. It's because 1 half squared is 1/4. Plus g times whatever our final height is. We want to ultimately solve for our final height, so I'll go ahead and do that. And we'll get an expression that looks like this. We have g, but we don't know what v naught is. However, we can figure out what v naught is by using the fact that we know the maximum height. So if we do another conservation of energy here, our initial situation, we're going to say it starts at the ground. So this is our launch. At the end, it's going to be at the top of its path. And at the top of its path, it's only going to have gravitational potential energy. So I have 1 half m v naught squared equals mg times its maximum height. We can figure out what v naught is using this. It's going to be the square root of 2g times whatever the maximum height is. And so then we can plug that into this equation here. And we'll note that these g's are going to cancel out, those 1/2s are going to cancel out. And so it's going to have a final height where its speed is 1/2, that is 3/4 of its maximum height, which is going to be 3/4 of 16, which will be 12 meters. Hope that made sense, and I hope that helped out.